Hi, everybody. I'm Nick. I work with the remote execution team in Waterloo. I work on tool chains for the remote execution team. We're also the owners of Rules Docker and Rules Kubernetes. We build containers. We build the container that we use for all remote execution builds. And we're also the owners of the Bazel container now. So this talk is just about focusing on what is different between remote execution and local execution. We're going to be going over some of the main challenges that we have faced ourselves and we see our customers currently face when they're trying to get their local build to work with remote execution. OK, before we dive into the main topics, I wanted to get some terminology out of the way. First of all, the host environment is the machine where Bazel is running, the machine where Bazel is installed. It can be a Mac or a Windows or a Linux machine. And the execution environment is the machine where the commands that Bazel spawns will be running. Now, with remote execution, these two machines are likely to be different. And currently, with our implementation of remote execution, the execution environment typically is a Linux system, whereas the host environment, we would like to be anything, right? We would like it to not be restricted to you having to build from a Linux machine. You should be able to build from a Mac machine or from a Windows machine. And then the target environment, I just mentioned it here for completeness. I'm not going to talk too much about that in my slides. It's just where the binaries that you're building with Bazel will finally run. OK, the first thing that we should ask ourselves is why is it not just trivial to do remote execution? And we had a couple of talks during this conference that have touched on some of these topics. My take on it is that Bazel allows you and empowers you to create a build that is fully hermetic and fully reproducible and fully replicable, but it doesn't actually enforce you to do it. You can build things in Bazel that are not hermetic and not reproducible. And these just happen to work by accident when you do a local build. But when you start moving to a remote execution environment, these typically result in hard failures. And even though these things work locally, the main takeaway that I'd like you guys to take is that all of these things that we're going to go over in this presentation, they can also impact your local builds. So if you often find yourself having to do Bazel clean because you don't know why, you're probably doing one of these things. You probably have in your build a problem related to this. So some of these topics are very related to the talk that Matthew gave yesterday about hermeticity. So we'll talk about each one of these in detail. Before that, the key difference about remote execution and local execution, Stephen also touched upon this topic on his presentation yesterday, is that actions are isolated fully from one another. There is no way that anything can leak from one action to the other. Anything that happens with the build tools is just destroyed after the action is executed. And only the explicit inputs that you declare for a rule will be actually present at the moment in which the command that Bazel spawns will be run. So anything that you have not declared as an explicit input will not be there. And then as I was mentioning, we want to be able to build on diverse execution environments. We would like to be able to have a build that can run from a Mac on a remote Linux environment or from a Linux on a remote Mac environment. That's going to be much, much harder. But we would like to at least keep this option open by trying to understand all of the issues that we currently have to make this happen. OK, so who should care about this? Obviously, if you want to do remote execution, you should be looking at each of these issues and seeing how you can fix them. But I also think it's very, very important for anybody who's a rule owner to take good and close attention to each of these things. We have found that every user that wants to onboard into remote execution depends on third-party rules that are being developed by a diversity of teams. And a lot of the problems are in those rules. So we need help from the rule owners to get this working for everybody. And in general, if you just want to have your builds be more hermetic and more reproducible, you should also be caring about this, right? We also had a question during Stephen's talks yesterday about how to avoid poisoning your cache. You make your builds more hermetic. If your builds are fully hermetic and fully reproducible, you have no possibility of poisoning the cache. Now, that is not always possible, but the more that we move the arrow towards more hermetic and more reproducible, the more likely we are to never poison our cache. Okay, so I don't know which one's mine. So this is just a list of these issues that I showed you a couple of slides ago. We call them anti-patterns. And we're going to go through each one of these in the upcoming slides. So the first one is missing on implicit dependencies. This one is the easiest issue that we have seen, that basically every project that we try to onboard to remote execution has one or another action that is doing this. And the issue is that with local execution, if you're writing a gen rule or you're writing a shell test or you're writing something like that, it's really easy to just use a file that happens to be on the relative path for your run files tree and not declare it on your actual rule declaration. And that will work, but it'll be non-hermetic, right? So if the file that you're using is regenerated, your gen rule or your SH test or whatever will not know that it needs to rerun. So what do? Bazel clean, because you got a weird error, right? Sandboxing can help. If you're not using sandbox it, use it. It can catch a lot of these implicit dependencies. It can help you get your build cleaner. The big problem that we have, and Stephen also mentioned this yesterday, is that even with sandboxing, tools are hard. Tools are really, really hard to understand, and tools can do whatever they want to do. So the C compiler has 20 or 30 years of background where they decided that they will just find the files in your predefined directories, and there is nothing that we can do to change how these compilers work. And there are many other compilers that keep some state. I've heard that the Scala compiler is stateful. I have no idea what sort of state it keeps. But whatever state it keeps will be available to the next action that runs, if this is even with sandboxing. So we have been working with the Bazel team for a long time to try to get stricter form of sandboxing, and this is the local Docker sandbox. The way it works is that every single action that Bazel spawns creates a new container, mounts the inputs, runs the action, gets the outputs, and kills the container. As you can imagine, this makes the build much, much, much slower. So I don't think it's viable with the current performance to have your builds or your CI to use local Docker sandbox. But if you're thinking of remote execution, try to run a single build with local Docker sandbox, leave your build running, and come back in a couple of hours. And then see if your build is really, all of the dependencies for all the actions are explicitly declared. With remote execution, you'll just get an error, right? Anything that you haven't declared, you'll just get an error. So if you're trying to do your BYOB, bring your own build, if you're coming to this session or if you're thinking about onboarding, any error that you get that a file is missing, it's probably because you didn't declare it as an explicit dependency of the rule. Okay. Second anti-pattern that I wanted to talk to you guys about, this is it's a simple one, using platform-specific binaries. So when you start a local build, the assumption is that the host and the execution platform is the same. So it is very easy to just assume that you can have some binaries that are in your source tree or some binaries that are installed in your machine and that you can just use those for remote execution. But that will not work if you want your build to start from a Mac and be running on Windows. And the specific example that we have here is SingleJar. Up until about a year ago, the SingleJar binary is a C binary. When the first time you do a Bazel build after you install Bazel, you see this little extracting Bazel and some little dots. Part of what it's doing is it's unpacking the SingleJar version that works with your host. And the reason it's doing it is because this tool, SingleJar, is going to be used by a lot of projects and a lot of builds. Basically, anything that uses Java rules. And it would be too expensive to rebuild it for every project, so why not build it when you install Bazel and use it for every one of your builds? That works as long as you're not doing remote execution. The moment that you have a SingleJar binary that was built for Mac and you try to move that to the Linux remote execution environment, you're going to get some exec error. I don't know what the hell you asked me to execute. So the short advice for this is don't ship any build binaries or build tools that are required by your build with your source code. Prefer shipping sources, or if you must, make sure that your users can select which execution platform they're going to be running on when they get this pre-built binaries. So you would need to ship binaries for Mac or for Linux or for any platform that you expect your users to be using as execution platform, and make sure that you enable your users to pick this platform for your binaries. Okay, tools invoked incorrectly. This one is the one that most affects rule owners. Rule owners build rules, and those rules need to use tools or resources. We are also rule owners, as I told you in the beginning. We are now the owners of rules Docker and rules Kubernetes. And as part of our rules, we use, obviously, Docker, and we use kubectl, or however it's supposed to be said. So we use these tools, and currently in our rules, if you look at the bash code that we have to execute these rules, it actually says Docker run whatever we need to do. This is wrong. This is not the way that you should be doing it. This is the naive approach to executing these tools, but it's not hermetic. What happens if I run rules Docker right now? I build some targets. I then change my version of the Docker binary that I have installed on my machine. And then I continue doing my build. And it turns out that there's some incompatibility between the version that I had 2 minutes ago and the version that I have right now. If my rules are just saying Docker run or Docker pull or Docker push, Bazel will never know that that tool changed. It will not rebuild. So I will start getting these weird errors, and I do Bazel clean. Productivity is killed, right? So this is not hermetic, and it's not platform compatible. The correct approach, which now exists, the problem is that it does require additional effort, is to be using toolchain rules. So a Bazel toolchain is a configuration provider that tells a build rule what build tools to use and how to configure them. This is from the toolchains documentation. So instead of us writing Docker run in our rules, what we should have is a toolchain rule that says I am the Docker toolchain. I can specify in the Docker toolchain the location of the Docker binary. Maybe I can specify the version of the Docker binary that I'm using, and I can also specify some configuration file for the Docker repositories or for the Docker registries. And then in my rule, I just declare that I will be using that toolchain. I empower my user to specify which version of Docker they're using. And then I just pass these as arguments into my rules, and I am now able to invoke Docker in a way that if the user decides I'm no longer using Docker version X and using X+1, it's a new toolchain. My build, that any action that required using that tool will be re-executed and will catch the new version of the tool being used. Okay. We have another slide for tools invoked incorrectly, just for one special tool that we all love to use, the local JDK. So the local JDK has been a big problem for remote execution up until a month ago. Thank God that with Bazel 16, a lot of use cases broke with local JDK. We had foreseen that this would happen. The local JDK is a repository that is created automatically for every Bazel project. And this is a legacy repository. It's not created with a repository rule. It's created with code hidden somewhere in the Bazel binary. And what this local repository has are a bunch of symlinks. So this logic to create this local JDK, it actually looks at whatever JDK you have installed in your machine, and then creates a symlink from the run files tree to the jar tool, or a symlink from the run files tree to the Java C tool. And then it makes it available for any other part of your build to use it. The local JDK results in builds that are non-hermetic. So if I run my build from this machine that has a version of Java, and then I run a remote build from that machine that has a different version of Java, we will not be getting any cache hits. We will have to rebuild everything twice, because my JDK that was part of the action key will be different to the JDK that they sent in their action key. The same occurs if you're just using remote caching. If you're using remote caching and any of your rules uses the local JDK, you will not be getting any cache hits across different machines unless you convince your developers to all of them install the exact same version of Java. It has to be exactly identical. The good thing is that it's easy to solve. This one is really, really easy to solve. Just don't use the local JDK. The local JDK should be just an implementation detail hidden somewhere under the covers of Bazel. The right things to use are the current Java runtime and the current Java toolchain. We've been working with some rule owners to try to fix this because this was one of the biggest problems that we had. Here at the bottom of the slides, we have a pointer to the work that we did for rules Groovy and rules Kotlin. So if you have any rules that need to interact with any Java tools, please check these examples out. It's not easy to fix them, and the sooner you do it, the better, the more prepared your rules will be for remote execution. Cool. Okay, let's take a break because this one's the tough one. Okay. Configure style workspace rules have been my nightmare for the last 2 years because I have no generic solution yet for this problem. Configure style workspace rules are used for proving the host platform. So rules for NCC use us to find out if you're running on a Mac or if you're running on Linux. TensorFlow CUDA configure uses them to find out which version of CUDA you have installed. Python pip packages uses to install the pip packages, right? All of these things are incompatible with remote execution. And the big problem is that I don't have solutions for all of them. But I have an incomplete list of things that you shouldn't be doing in your repository rules if you want them to work with remote execution. You should never be building any binaries. Any binaries that you run, that you build on workspace rules will be built for the host machine where you're running your build. For the host machine where Bazel is running, not for the execution environment where the rest of your build is going to be running. Installing pip packages, the same thing. You will be installing pip packages for the machine where Bazel is running, not for the execution environment where things are going to be running. Symlinking to local tools or mutating the host platform, it will just not work. If anything on this nature is happening, you should try to not do it, and you should try to split it up so that the non-hermetic bits of your rule occur in the workspace rule, but anything related to building things occur in regular build rules. The problem is that this is not possible. I have here an example of how it should happen with pip packages. The problem is that the pip tool does not allow you to do this. Ideally, and with apt-get, you can do this sort of thing. You could do apt-get pull. That's what you would do in the workspace repository rule. And in the build rule, you would do apt-get install, that thing which you pulled before, right? With pip, you can do that, but that's what should be happening. The pip packages should be pulled in the workspace repository rule, which is non-hermetic. It is allowed to reach out to the internet and pull all these things. But the installation of these pip packages should only be happening on a regular build rule. Unfortunately, this is not possible for pip, at least. And I'm sure that there's many, many different things that it is not possible to break down the non-hermetic bits of the tool with the actual building and executing things. OK, so if you happen to find a rule that works like this, the only solution that we have for you today for doing remote execution is that you need to run your build from a host environment that is exactly identical or that looks sufficiently the same as your remote execution environment. Typically, what this means is that you will be running your build from inside a Docker container. And that is the advice that we give to users that are looking to onboard in remote execution and that they know they have this sort of rules. For now, that is all that we can do. Now, this effectively becomes problematic when you want to do builds from other OSs. Obviously, you cannot do this from Windows. But from Mac, you can do it. You can actually bring up in Mac a Docker container. If you do well the mapping of the files that you're going to be sharing between the host and the Docker container, it should work. And I think we have at least a couple of remote execution users that are currently doing that, just running everything from a Docker container that looks exactly like the one you're going to be using on remote execution. Now, mind you, just doing that does not only guarantees that you won't be having problems related to this anti-pattern, but the ones that we saw before, they're still valid. So even if you run from a Docker container that is identical to your remote execution environment, you can still have missing dependencies, and they can still result in errors. OK, this last anti-pattern that we have here, it's about mixing execution strategies. So for those of you who are not familiar, Bazel offers a bunch of different execution strategies. It offers local execution, sandbox execution. I think there's 2 versions of Linux Sandbox. There's the local Docker sandbox as well. There's the worker strategy, and then there's remote execution. Unfortunately, as far as I know, they're exclusive. You cannot do, and we had this question commonly asked by folks who have Scala projects that are wanting to migrate to use remote execution. Worker strategy does not at all, it's not at all compatible with remote execution strategy. Worker strategy expects there to be long-lived workers, and remote execution expects every action to be executed on a different environment, so there's no way that we can currently make these two work together. However, it is currently possible to provide some strategies as fallback, to say this action in particular, my whole build will run remotely, but this one action, you shouldn't run that remotely. The problem is that it's really hard to do it right. It's really easy to do something that works today, but tomorrow it will not work. And the key limitation that we currently have today is that with right now in Bazel, you can only define one host and one target platform. And that means that if you're having to do local fallback, that same platform should be valid for your remote execution environment and for your local host environment. So the only way that I know of that you can really do this right is by falling back from remote execution onto local Docker sandbox execution, and by specifying that the remote Docker execution environment is the same one that it's going to be using for the local fallback on local Docker sandbox. In that way, you can 100% guarantee that the platform is going to be identical and you should have no issues at all. But in most other cases, I would not recommend falling back to local in general. Now, it's true that you can assume that it's going to be safe to fall back to local, particularly for platform agnostic rules. So if you have a rule that creates a tar file, you have a rule that creates maybe a jar file, you might think that those are relatively platform agnostic, so you can maybe create one jar in the remote execution environment and create another jar locally. This will only work if the toolchains are identical in the remote and local execution environment. That means you need to have Java installed in the exact same location remotely and locally. That's why doing the fallback locally onto the Docker sandbox will work, but any other form of local fallback is very problematic. And the worst situation that we want to be in is something that works today, just because my CI happens to have Java installed in the same location as my Docker container, but that 6 months from now you decide to change your CI, or I decide to change the container, and your builds break. That is what we want to avoid. Okay, so as I was saying, this really will only work if you have the same toolchain available locally and remotely. Hopefully, once platform allows us to do more custom selection of what the remote platform is and what the local platform is, we should be able to say things such as, for Java, this platform that works remotely and this local platform, they're equivalent. So any artifacts that were produced locally or remotely should be safe to pass around these rules. I'm not sure exactly how that will work, but I know that with platforms, it should at least be plausible to do this. One thing that's for sure is that even when we have these platforms, this will only be feasible for rules that the outputs are platform agnostic. So if you expect this to ever work for C++, I don't think it will. I don't think it's ever possible to get a binary built on Ubuntu 16.04 and to get that binary transferred to Debian 8 and to have that just work. I tried it a lot and I couldn't get it to work ever. If anybody has got it to work, I'd be happy to know what you guys did. Okay. So that's it for the anti-patterns. I just want to go ahead and recap that a lot of things just work locally by accident because we're running in the same environment in both cases. But in general, if you're doing Bazel clean, this is just a symptom of having problems that you should be solving. And if you're just looking at remote caching, this is also going to be a problem to you. I just spoke earlier today with somebody who's got a poison remote cache because of some symlinks that TensorFlow is building. I'm not surprised at all. With remote execution, all of these problems will become hard failures, and yes, let's fix them all. So yes, using remote execution requires your builds to be as hermetic as they can be. And although this does take some effort to get it working, it's good. Your build will be better in the end, right? You will be having less developers complaining about having to do Bazel clean. Okay, so before we go to questions, I have a couple of links here to point you guys to. The first one, remote execution rules, is a summary of some of these anti-patterns that we talked about. The second one is about the remote execution, about using the local Docker sandbox to verify if your build will work with remote execution. And if you're a rule owner, we just published yesterday in Bazel Docs a new document so that you can set up your CI if you're on GitHub and you're part of the Bazel org in GitHub. It should be very simple to just set up your CI with BuildKite to run some targets with remote execution so that you can start progressively making your rules work better with remote execution. If you're a rule owner, please check this out. Come talk to me. I am happy to help you get your rules working with remote execution. I think we have around 8 or 9 rules that are currently running with BuildKite on remote execution on every PR. So we're really happy that these rules are now fully compatible with remote execution, and we want every single rule to work. Cool. So.